So I do have a PhD, and I figured, well, I can give this presentation. My experience is a little more distant than the recent student's presentation, but I'll go over some of the basics of a PhD program and some things you should think about if you think you're on this track. So first question you should ask yourself is, why am I getting myself into this? Why do I want to pursue a PhD? Why does this interest me? And it really does take a certain type of personality to get involved and be dedicated to research. So these are some of the characteristics I think you would find for people that are research-oriented. The first and foremost is, do you like learning? And do you like learning all the time? And not necessarily just about your one specific project in the lab, but do you just like learning in general? A PhD is a ticket to lifelong learning, self-directed learning. So does that get you excited, being able to learn new things? There's a documentary on PBS a while ago about graduate students in a structural biology lab in New York City. And the name of that program was called Naturally Obsessed, which is perfect. That is a perfect description of a PhD candidate. You are just obsessed with what you're doing. You think about it all the time. You think about it during breakfast, you think about it in the shower, you think about it over dinner, and all day long. Not because you have to, not because you're told to think about that, but because you want to, because it's that interesting to you. So if you have that type of personality, that you always like learning and you like problem solving, because that's really what we do in a research lab, we solve problems, then maybe the PhD, the research track, is for you. And of course, you have to like working in a lab too. That's part and parcel of the PhD. You're going to be doing research. So do you like showing up to the lab and being in the lab? Do you like pouring gels? Do you like running experiments? Do you just like the day in and day out routine of being in a research environment? Are you meticulous and determined? And I put up here, you can be meticulous. That doesn't mean you have to be meticulous all the time. When I'm at home, I'm a little sloppy and lazy. But when I'm in the lab, I'm very precise and cautious and careful with what I do. And you have to be that way in the lab. If you're sloppy, if you're lazy with what you do, things are never going to work. There are 100 different things that can go wrong with an experiment, and that's an easy experiment. So if you aren't meticulous, if you aren't cautious and careful, something's going to get messed up and your experiment's not going to work. So if you can be very precise and meticulous in your work, you don't have to all the time, but you can do that in the lab, then this career track could be for you. And you have to be determined too, because those experiments don't always work even when you are careful and meticulous. So if an experiment fails, are you determined to get it right? It may take a few tries, it may take a few weeks, it may take a couple months, but can you stick with it? Are you interested enough in what you're doing to stick with something that isn't working at the time, but you can get to work? And you have to have a thick skin too. So you have to be able to deal with those setbacks and those failures that are inherent to research. You also have to be willing and able to take criticism. When you're in a PhD program, you're going to be judged and graded all the time. You're taking classes, you're going to get grades, you're going to have oral exams where faculty test you on your knowledge and question your data, question your project. You have to be able to deal with that. You have to be able to deal with the criticism. When you submit a research paper or a grant, people are going to critique that grant and point out the strengths and the weaknesses of that proposal or that research. Can you deal with that? Can you deal with somebody telling you that's really not the best idea? And if you have a thick skin, you can do that. You also need to be a little bit humble too. Sometimes they're right. Sometimes you don't design an experiment properly or you don't have the best idea, and you have to know when to accept that advice and realize I should integrate that into my research. And you need to know when you really are on the right track and you should continue to pursue the idea you have. So these are the types of traits you see in people that are focused and interested in a career in research. And if you look at this list of questions about your personality, you should realize that your PhD training really starts now as an undergraduate. You're going to learn about the lab environment. You're going to be potentially naturally obsessed with immunology or biophysics or a particular topic as an undergraduate. So you're starting your training now. I started my training at the University of Arizona, where I was an undergraduate, and like UCF, the U of A was a great place for undergraduate research. They had a lot of opportunities available. They were very supportive of undergraduate research. And I was lucky enough to do 3 years of undergraduate research. I worked in 3 different labs, 2 short-term projects, and then a long 2-year project in my major lab. And during that time, I got hands-on training. If you're working in a lab, you're going to be using your hands. You're going to learn how to pour gel, use the pipette min, make your own buffers and solutions. Things that maybe you do once in a lab class, you're going to be doing on a routine basis in the lab for your project. And you're also going to apply the knowledge you learned from classes. So there will be concepts you learn about in class, and then you get to apply them in the lab. And vice versa. There'll be things that you learn, self-directed learning in the lab, that you later hear about in a class, and you already know that material. Both of those situations are really satisfying, at least for me they were. It's this type of aha moment where you get to see something, an abstract concept in a lecture hall applied in the lab because you're actually doing it. You're actually learning about that. And that's a very powerful learning experience. And then you get practical experience as well. And practical experience kind of feeds into these 2 things, the hands-on training and the applied knowledge. But practical experience also means you just understand what it's like to be in a lab. You know what the culture of science is like. You know the routine of lab work. You know what people are concerned about, how people behave in the lab, the rewards and the frustrations of being in a research environment. And so that practical experience is also key because you need to know what you're getting yourself into if you're going to apply for a PhD program. So we had a question in the previous presentation about do you need a research experience to get into a master's program. And for a master's program, you don't necessarily need an undergraduate research experience. But for a PhD program, you really do. Because a PhD is going to be 5 to 7 years. So you need to know what you're getting yourself into. A PhD program is going to put a lot of time and resources into you as a PhD student. So they want to know that you're going to stick it out, that you know what you're getting yourself into, and 1 to 2 years into the program, you're not going to bail out because research really isn't for you after all. So that undergraduate research experience gives you that practical experience to know that this is the right career track for you. Now, if it is the right career track, what do? You put together your application. And these are the 5 basic components of a PhD application. They mostly carry equal weight except for the personal statement, which might be a little lower weight than the other categories. So you have to take the GRE, as Carly mentioned in her talk, and there will be a minimal GRE score that you have to meet in order for your application to be reviewed. And in most cases, that is a hard score. If you're below the minimum GRE score, they won't look at your application for a PhD program. Obviously, the better your GRE score is, the better your application is going to look. If you just make it over the hump of the minimal GRE score, you're going to be in the lower part of the pile of applicants just to begin with. We also look at your GPA and your transcript, what classes you took and what grades you got. And we look at that as a holistic, what's the word I'm looking for? A holistic part of your education. And what that means is if your GPA is on the lower side, but we look at your transcript and your grades started low freshman and sophomore year and then got better, then that's positive, that's okay. The reverse situation would be much more difficult. If you started strong, but you have all C's in your upper division restricted electives, that's kind of a red flag because those are the courses you really need to excel in. So we look at GPA, but not just as a number. We look at what classes you've taken and what you've done well in and what you haven't done well in. And there was a question in the last talk as well about the balance between the GRE and the GPA. And we do kind of look at that too. If you have a 3.8 or a 4.0 GPA, but you just barely pass the minimal requirements for the GRE, that's not going to look so great. But if your GPA is okay, but not super, and you have a GRE score, that actually looks better for the student. We also look for that research experience. Like I said, it's important that you know what you're getting yourself into. So you have to have a research experience to have a good shot of getting into a PhD program. And we also look at your resume or your CV that goes with that research experience. If you only have a one-semester research experience, that will help, but it does generate some doubt that maybe this was a last-moment idea on your part. Maybe you're not really committed to a research career yet. On the other hand, if you have a couple years of research or you have a lot of research-related experiences on your resume, that's a good thing. So if you've had a research experience and you presented your work at a conference, either a state conference or a national conference, or you did honors in major, or you're part of the ASM club, if you did extra things on top of your research experience, that shows you're really dedicated and interested in the field, and it shows extra motivation. So Carly, when she was here, was a professional undergraduate. She applied for just about every opportunity that was available, and her CV looked fantastic. It was obvious she was very interested in a research career because she had participated in all these programs and had done all of these events related to the research enterprise. So that can help make your application stand out. In addition to the research experience, you're fully invested in a research track career. That research experience will also get you at least one good detailed letter of recommendation. And like with the master's program, they generally require 3 letters of recommendation. So you need one really strong letter, at least one, and that should be from your faculty mentor from your research experience. If you do something like honors in major, you'll know 3 faculty members and can get letters from each member of your committee. A usual application packet will have one very strong letter from a research mentor, one letter, a second letter from somebody else that knows you and knows your abilities in the lab, another faculty member that's in the building or is on your honors committee, something like that. And usually the third one is just somebody from a class you've taken that says, this person was in my class, got an A, asked a few questions. And that's about the most they can say about you. So if that's you, if you can't find 3 really good letters, that's usually okay. The third one, it's hard to find 3 faculty members that know you well. You need to find at least one. That should be from your research experience. And preferably 2 people that can say something specific about you, detailed about you, and what motivates you. And you can tell the committee, the admissions committee, directly what motivates you in your personal statement. And I personally think this weighs a little less in the application because most of the personal statements really kind of blend together. The personal statement is your opportunity to tell about yourself, what motivates you, why you're interested in a PhD, why you're interested in that specific program. But most people have similar interests and motivations. So it's not really necessary to stand out in the personal statement. It's just important to provide the committee with an idea of why you are applying to that program, even if it's the same reason everybody else is doing it. If an application stands out, that's great, but it's also likely that an application could stand out in the wrong way, right? If you try to make it stand out, that may backfire. As Carly mentioned in her talk as well, you can use your personal statement as a way of explaining if you have some sort of weakness in your application. So if you had one semester with a low GPA and otherwise it looked great, you could explain, I had a prolonged illness that semester, or I had to take care of a sick family member that semester. Or when I came to college, I was not prepared to study and I did poorly. But by the time I got to my junior and senior year, I developed good study skills, and you can see that reflected in the better grades I got from the upper division classes. So your personal statement is meant to explain why you want to go to graduate school, and you should tailor it for each school. Why do you want to go to this school? Why do you want to go to that school? And if there's any inconsistencies in your overall application, you can use it as an opportunity to address those potential concerns of the committee. Okay, so you've put your application together, and the next question is, where do I apply? I want a PhD, but what program should I go to? And so this is really a matter of personal opinion, and these are some of my suggestions, some of my advice for what you may want to think about when you're applying for a program. And this would apply for master's or PhD programs, and to a certain extent for medical programs as well. where you get your final degree is what people look at. So if you get a PhD or you get a master's degree, people don't really look at where you got your bachelor's degree from. It's that final degree that's important. And so it's important to get into the best school you can, because that really does open doors and it really does make a difference. If you have an application from, well, I won't insult anybody, so I'll say a random state school versus Harvard, and somebody else is from Harvard, the person from Harvard is probably going to get the first look just because of the name of the school they went to. So if you can get into one of the elite schools, a name brand school, a school when you say Harvard or Yale or Stanford or something like that, people immediately think high-powered intellectual environment. That's great because it will open doors for you really for the rest of your life, because your degree follows you wherever you go. So you want to take an honest look at your application and ask yourself, what's the best program I can get into? What's the highest level of program I can get into? And apply to those programs. Maybe apply to a couple even higher, because the most they can do is take your $20 application fee and say no, right? But you want to aim high, and you also want to triangulate so you actually get into a program, a good program that you would want to be part of. So shoot for some high-level programs, have a couple fallbacks, but then try to equilibrate where you think you can really get into these programs. I was always interested in what I called umbrella programs, and those are programs where they have one PhD supervising all the departments within that discipline. So, for example, larger research universities may have a department of genetics, a department of chemistry, a department of cell biology. I was attracted to PhD programs where all three of those departments were part of the same PhD program. And that opens opportunities for additional research experiences. So in an umbrella program, if you're accepted, you can go into genetics or cell biology or biochemistry. Whereas if you are accepted to a PhD program in cell biology, you're going to be doing cell biology. So the umbrella programs give you more options. And they also provide more opportunities for learning, because you're going to have classes available in cell biology, genetics, and biochemistry. You're going to have journal clubs and seminars on all of those topics, rather than just one specific topic from one specific department. So I would recommend applying to programs, single PhD programs that encompass all the life science departments on that campus. And that would give you many opportunities for exciting research. If there's one specific person you want to work for in a PhD program, you probably shouldn't apply to that program, because what if that person doesn't take you? What if that person doesn't take any student, or takes another student, or runs out of money, or moves? You know, if you put all your eggs in one basket, you could very easily be disappointed. So you want to look for programs where you have 3, 4, 5 different faculty members where you would be interested in working and happy to work with any of those faculty members. And that, again, feeds into the idea of umbrella programs where you have lots of faculty members to choose from. So do your background research, look at the specific faculty in a program, and figure out, yeah, there are a handful of people there I'd be really happy to work with. And you can even include that in your personal statement, that I'm interested in molecular biology, and these 3 or 4 or 5 faculty members are doing things I'm really interested in and could see myself working in that lab if I'm admitted to your program. These things are also important too, where the program is and how comfortable you are with the program. So I would recommend moving away, maybe I shouldn't say this on tape, from UCF for your PhD program. You should go somewhere else. And that demonstrates independence, that you can move somewhere else and be successful somewhere else. So when somebody's looking at your CV again, they can see you've moved at least once, you've reestablished yourself, and you've been successful in a new environment. And also, you know, just honestly, this is a time in your lives where you guys are mobile and don't have a lot of restrictions. So now is a good time to go out and experience the world. You can move to a place, you can live in an apartment in a big city for, 5 or 6 years, and it's okay at this time of your life. As life goes on, you accumulate additional responsibilities and additional concerns come into play. But at this point in your life, you can go somewhere new, somewhere exciting. Yeah. No, it wouldn't be that. I don't think you'd be rejected from an Alaskan program because you're from Florida. No. It's more of later in life when you're applying for a job in industry or a faculty position. If you've lived in Orlando your entire life and you did high school, undergraduate, PhD in Orlando, and a postdoc in Orlando, then if you want to move to Alaska, they might say, well, that person may not want to come here. They've never been outside of Orlando. So it is good to move just for the personal experience of being in a different environment and experiencing a different location. And it also does show some amount of independence and ability to succeed in different environments. Comfort is also important too. So you want to factor in all of these things, but you never want to go to a program where you aren't happy with that program and comfortable with that environment. Most well-funded PhD programs, if they're interested in your application, they will invite you out at their expense for an interview. And it's really a combination recruitment and interview, because if they're going to spend money to bring you out, maybe fly you out across the country, they're obviously interested in you. But at the same time, they haven't accepted you yet. And as our first speaker mentioned, that interview is to make sure the person on paper is the person in person, that you really represent what they see on paper. So they're interviewing you, but they're already spending money on you, so they're going to recruit you at the same time, show you what their program is like, show you what the city and the environment is like. And that is the great time to get an idea of, are you comfortable in this environment? They don't do that for medical school, right? You have to go out on your own dime, if at all. And I would recommend doing that for any program you're accepted to, because you should know what you're getting yourself into before you get there. For example, when I was applying for graduate programs, I applied to the graduate program in the medical school at Johns Hopkins, which was in downtown Baltimore. And back in the day, that was a very dangerous place. It's much nicer now. But when I went there and interviewed, they had armed guards at every door. And you had to show ID and sign in. And that included the faculty members that were escorting me around. And they had cots in their labs, because if you were there after dark, you slept in the building and did not leave the premises. So obviously that was a place I was not comfortable with. And if I had just accepted admission to that program sight unseen, I would have been sleeping on a cot for 4 or 5 years and been very unhappy about that. So that interview process lets you know if this program is right for you. Are you comfortable with the environment? Are you comfortable with the program, the faculty, the students? Are you ready, as Carly mentioned, to marry this program and have it become your family for 5 or 6 or 7 years? So I married Cal Berkeley. That's where I went for graduate school. And it was because of the interview process. When I went there, I can't really describe it other than to say it just felt like home. It just felt right. Being on this beautiful campus, the faculty, the students, the city of Berkeley, everything was just right and perfect for me. And I hope you guys experience that when you apply to a job or a program, that you just know. You just know that this is the right place for me. But you have to go there, right, to figure that out. So if for PhD programs, as I said, they should bring you out there. If you're applying to other types of programs, you should still make the effort to go to that city, to go to that university, and see if it's really right for you before you make the commitment. Okay, so you make the commitment, you're admitted to the PhD program. What comes next? What comes next is your training in the PhD program. And in the first year of a PhD program, you usually work in 3 different faculty labs, 3 or 4 different labs for about 10 weeks at a time. We call those rotations. You don't immediately start your PhD dissertation work the day you step into a PhD program. You're going to work with 3 or 4 different faculty members over that first year, and you're going to figure out which lab is right for you, which particular lab is best suited for you. And the faculty members are going to do the same thing. Is this somebody I really want to support for the next 5 to 7 years? Well, let's find out through the rotation period. This differs a little bit from the master's program. If you're admitted to a master's program, you pick a lab and start basically the first month of the master's program. And that's because the master's program is only 2 years. You have a limited amount of time to get your project done. But because the PhD training is longer, we take the time to do rotations and find the right match of student and faculty mentor. During that first year, you'll also be taking classes as well as working at the bench for your rotation. You might take classes in the second year as well. This is really dependent on each PhD program. Some programs have very minimal class requirements. Other programs may have 2 full years of classes, so it just depends on the particular program you're attending. Almost all programs by the end of the second year will have a qualifying exam which advances you to candidacy. This is a milestone in PhD training. This is an exam that's meant to determine whether you are truly prepared and able to become a PhD. Yes. 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 When you're in a PhD program, you receive a stipend and a tuition waiver. So you're compensated, not well, but you're compensated. You're essentially an indentured servant. Just like Carly mentioned in the last talk, you have no time for another job. You have no other way of supporting yourself because you're expected to either be in the lab or be in the classroom at all times. So since you don't have time for another job, we pay you. We pay you for your time in the lab, either working as a research assistant in the lab or working as a teaching assistant. So that year 2 is a big event. That's your qualifying exam. It's usually an oral exam where you will think of a research problem, design a series of experiments to test that problem, and then defend it in front of your committee. There also may be a written exam as well. If you pass that, then you're advanced to candidacy, and then you will spend the next X number of years just doing bench work, working on your dissertation to get the body of work done that you can defend when you're done with the PhD. After that first or second year, you won't be taking classes, but you love learning, right? That's why you're in a PhD program. So you're going to be going to journal clubs and seminars and conferences for the entire tenure of your PhD program. And you may also be a teaching assistant as well. So in that first year, when you're doing your rotations, you're just kind of floating within the program. There's nobody responsible for you. And so the program pays you for that first year. Often they pay you in response for being a teaching assistant. So if your PhD program is at a research university, you'll probably TA at least 2 times during your PhD training, and at least once during the first year. If you're at a medical school, there's really nobody to TA, right? You're not going to TA a medical student when you guys are essentially peers. So that's something to keep in mind. If you're interested in teaching, you probably won't have an opportunity to do that if you're in a PhD program at a medical school. But if you're at a research university, you will TA. It's just a matter of how much teaching you'll do. So after all this is done, 5 to 7 years of work, you have your dissertation defense. You have a body of work that you can call your own. You've learned something new. You have rock-solid data that you can defend. You write it up for a written dissertation, and you give an oral defense of your work in a public seminar. So it's advertised, friends, family, whoever come out and listen to what you've been doing for the past 5 to 7 years. After that public presentation is done, the general public is shooed out of the room, and then you are grilled by the members of your dissertation committee, just like you have a master's committee, until you break down and cry. And then we let you graduate. Now, it can be very rough. It depends on your committee. It depends on how well you are prepared. This is part of the thick skin. You can get very penetrating, very difficult questions from your committee, but you should be prepared at the end of this time frame to handle those questions and to deal with those difficult questions. Okay, so what do you get at? Why would you bother to go through with that? What do you get out of a PhD? Well, there's some things I put up here as tangibles, which I think are really objective things you can get. There's no doubt that you have these things. You have bench skills. You've been working at the bench for 5 or 6 or 7 years. You know how to work in a lab. You know how specific techniques work. You didn't just run a qPCR once in a teaching lab. You did it weekly for 4 years. You know how that process works, and you can do it. And so when that's on your CV, people know you really understand that technique or this set of techniques. You have a publication record, and just like your PhD, that will go with you for the rest of your life. Nobody can take away your PhD. Nobody can take away the papers you publish. And that publication record demonstrates the knowledge you generated and the work you did during your PhD training. And then on your CV, you'll also have a list of presentations you gave at local or national conferences. Maybe you won a fellowship, a grant, something of that sort, scholarship. All of those are things that you can say definitively, I did this. This is what I did in my PhD training. And then, of course, you get a PhD from a specific university. And I again put specific university because, just to emphasize, the name counts. The higher tier university you get your degree from, the more doors that will open for your career as you move forward. And this gets back to you do get paid, not a lot, but you do get tuition and a stipend for being in graduate school. So you don't have to go out and find another job, which you wouldn't have time for anyway. Now you also get some intangibles, and this for me is the most important part of a PhD. A successful PhD can think. Not a lot of people can think, but a person with a PhD has learned and honed their critical thinking skills. And those are portable skills. No matter what you do after your PhD, you could leave science, you could switch from one discipline, science, to another. You have those skills available. You can think through a problem. And those are very important skills. You also have friendships. It's kind of a band of brothers type thing where you have a group of classmates. You're all going through the same trials and tribulations together, and those friendships last. Same thing with your mentor relationships. Your primary faculty mentor as well as the members of your committee, especially a PhD committee that spans 5 years or longer. You're going to get to know those people. They're going to get to know you, and those relationships are going to stay. Okay, so you finish your PhD. What do you do next? Well, if you're on an academic or a research track, you're going to do what's called a postdoctoral fellowship. After you've earned your PhD, you should be able to think independently. You should have those critical thinking skills. You should be able to operate as an independent scientist. But you're still fairly green, new to the field. And so a postdoc, an ideal postdoc, is an independent project that you spearhead yourself, but it's done in an established faculty member's lab. And of course, you're going to work on a project that faculty member is interested in. But it gives you a chance to work independently. And if you struggle with that independence, you have an established faculty member that can keep you on the right track and make sure you're still making progress. That can last 2 years to forever. Some people never leave the postdoc. They don't want to leave the postdoc. We call those people staff scientists. They just kind of hang around and do a postdoc forever. And really, in research, the postdoc is the best time for research. You've got your PhD. You don't have to take classes. You don't have to defend a dissertation. You don't have to do your qualifying exam. All you have to do is show up, think about your project, design an experiment, do the experiment, interpret it, and go home, and then come back and do the same thing the next day. You don't have to worry, as like faculty members do, about teaching and service and administrative duties and all these other things you were never trained to do before you get onto that job. So many people don't leave the postdoc. They don't want to leave the postdoc. They just become staff scientists because they love being at the bench. You can do the same thing in industry, too. You can go from a postdoc to an industry position. If you want to go into industry, it's even better to find a postdoc in industry because that kind of becomes like an internship. And then you transition from a postdoc to an employee, a regular employee for that company. The postdocs can last for different amounts of time because if you're on an academic track and you want to become a faculty member, you need to generate a body of data and a project that you can call your own and take with you from the postdoc to start your own lab. Sometimes things work great, and that may only take a couple years, but sometimes things don't work very well, and it takes a long time to develop the data and the tools to start your own lab. So my postdoc was 6 years. That was a fairly long postdoc. But when I finished that postdoc, I had a couple of publications, and I had tools, and I had a project that my mentor, my faculty mentor, luckily let me take with me to start my own lab here at UCF. So the postdoc kind of gives you a running start on your own research program if you find an academic position. You can also go into government too, just like industry or staff scientists, and you can just do research all day long if that's what you really love. Or you can do a postdoc and then decide to do something else with that. Or you can skip the postdoc altogether and do other. you have critical thinking skills. You have a portable skill set that is in demand. So you can combine your critical thinking skills with one of these other disciplines as well, especially something like business and law. There are many people who have an MBA, many people who have a PhD in molecular biology, life sciences, but not many people who have both. So there's a real need in industry for people that can translate between those two disciplines. Somebody with a business degree that also understands the science, a scientist that also understands the business. That works for this. It also works for law. I have two friends that have PhDs and law degrees. One of them went directly from her PhD to law school. The other one went from a postdoc to a law school. And in both cases, what they really did was go to work for a company in industry, and those companies paid for them to go to law school. And the reason for that is they didn't have any lawyers that understood the science of the company. So those two friends of mine are the interpreters of that company. They can translate law to the scientists, and they can translate the science to the lawyers. You can also go into education, science writing. You can do a lot of things with your PhD, either related or not related to science. When I was finishing my PhD, I had all these emails from consulting companies, business consulting companies that had nothing to do with science at all. But they were companies, you guys know what consulting companies are, right? They are independent contractors. They go into a business. They analyze that business, figure out what works and what doesn't work, and tell the company how to improve. Well, the reason they were advertising for PhDs is PhDs can think, right? So you can think through a problem. You don't have to know that business. You can go in there, learn what the business does, analyze the business, and generate a conclusion based on that. So you can do a lot of things with a PhD in addition to working at the bench. Yes? Usually you would do both at the same time. So you would do MD, PhD programs. And if you're interested in medicine and research, but you really want the medical degree, you can do research without a PhD. You can go to medical school, and like our first speaker mentioned, you can take the time to work in a research lab, either clinical or basic sciences, and you can learn research on the side while you're in medical school, and then make the decision, do I want to practice medicine, or do I want to spend more time at the bench? And if you spend more time at the bench, you'd probably take an academic position at a medical school, you'd be an MD, but you'd be doing research. It would be very, very time-consuming to do them consecutively, to do a PhD and then come back for an MD, or the other way around. So you can go to medical school and do research without the PhD. If you get a PhD and try to practice medicine without a medical degree, that's frowned upon. You'll probably go to jail for that. All right, I think on my last slide, this is just to give you an idea of the leg up you get with a PhD. And I pulled this off the web from the U.S. Bureau of Labor Statistics, and up on the top are PhDs. And I don't think that's even STEM specific. That's all PhDs. I imagine the English PhDs may be dragging us down a bit for employment numbers. But this is all PhDs. So if you have a PhD, and apologies to English majors out there, that's just a joke. If you have a PhD, you're much less likely to be unemployed than people with less education. And you're also likely, on average, to make more money than people without a PhD. So if for no other reason there's a mercenary approach to the PhD, that you will be more employable at a better pay than people that do not have a PhD. So usually my seminars tend to end on a down note. I think this one ends on an up note, so that's good. So I'll end with this. And if you guys have any questions for me, I'll be happy to answer. Yep. Mm-hmm. Most medical schools will have an opportunity to do research. UCF is fairly unique in that they mandate it. And so if you go to UCF, you will do research for at least 1 to 2 years. But if you go to another medical school and you have an interest in research, You have to find time to do that, but you can do it on your own. Oftentimes, like our first speaker said, you've got time in the third or the fourth year where there's a slot open, and it's up to you to find a mentor, to find a lab that will take you, and to begin doing research, whether it's bench work or clinical work or whatever type of research it is that interests you.